Okay, so if John invests $5,000 in a savings account that pays 6% interest compounded monthly, and I specifically ask for the future value of that money after 4 years, can you tell me what formula did you use? What numbers did you put where? Can you help me out? I'll take a volunteer. Look at all those hand things, Justin.
5,000 times 1 plus 0.06 over 12 to the 12 times 4.
Good. You put in $5,000 for what terminology are we using? That is the present value of the money. I'm looking to see what is the future value of the money. So to find that future value, I can stick in the present value, have it undergo the interest adjustment, and then have it undergo that compounding. Can I get a or just Jasper, you want to read off your money?
6,352.45 cents.
And what?
45 cents.
Very good. How'd we do? Decent? Okay. So did you comment at all? What did you write about what is unrealistic about this? Yeah, Lily?
It probably would be compounded monthly because they racked up a lot of money in 4 years.
Yeah, that actually, I agree, that actually is quite a bit of money. There are other things. What else? She is right. That's quite a bit of money in just 4 years. You what?
I wish I had that savings account.
Okay, why else though? There's another reason. Because if you have a savings account, there's something else that's not. Yeah. Say again.
More long term.
Meaning.
Longer than 4 years.
Yes, I like that idea too, Eric.
6% is unrealistic.
Yeah, 6% for just a basic savings account, which is I thought also what Lily was possibly alluding to. 6% can be quite high for just a basic, and actually is very unrealistic for just a basic savings account. So for example, at Fifth Third, there have been times in the past, I don't know, I've been with them for a long time, they've been anywhere from like 2%, 3% to 0.95%. Like really, really low for just a basic savings. What else? Yeah. I don't know that I am equipped to endorse any specific bank whatsoever. Financial institution. Anything else about this? Yeah. Yeah, I do agree with that. That's true too. What else? Just think about how money works. What do you typically do with money? Yeah, you put it in, but then you take it out. Or what else? If you're not spending it, what's the likelihood? Like, what else is a little bit unrealistic about this specific scenario? Go ahead. You could be adding more. And depending on how much you sit around and talk finances in your family, or perhaps if you're in some of the business classes, one of the things you know can be true is that you can make what we're going to refer to as equal periodic payments. And on this slide, which is on the next page for you, we have an official definition, and I'm going to go for a minute in between this slide and the previous one. And this official definition addresses the ability to put more money into an account. Specifically, when I put payments in that are of an equal amount and that are periodic in nature, meaning every month or every quarter or even every year can be equal and periodic. So there are a couple different scenarios that you may know of. Can you rattle off things where you've heard someone make equal periodic payments, meaning per month, per quarter, or there can be different directions of money, obviously. What were we going to say? Okay. A better example would be like a mortgage, right, which is what we're going to get to next week especially. Yeah, I make equal periodic payments to pay off my loan. Give me another one. Retirement, right? That's a huge one. So either whether it's your parents or whether it's just even any of us who either put into STRS or put into like the 401. Okay, thank you. We're often putting in equal periodic payments, right? Every paycheck. So I get paid twice a month. So that's not monthly, but that could be considered 24 times, right? 24 times per year that I take money out of my paycheck and I put into a 401k to build towards my retirement. Here is another one. Your parents may have set up a college account for you. So especially depending on if your parents were super young, it may have sounded something like this. You have a college savings fund set up. You have just $100, right? Because especially if your parents were super young, taking out $100 of a small paycheck may have been a stretch, but you know you want it to go towards a college fund. So every single month, $100 is taken out and put into this account. So there are things we need to know about the account. And there are a couple things that we're going to pay attention to. One is the interest rate. So depending on different types of accounts can determine what that interest rate is. When I was in college, I was a bank teller for my college job. And we would answer the phone, we would have to answer questions, not just about savings and basic checking, but about certificates of deposit, specifically about money market accounts. So depending on how savvy you are in that world, you know that oftentimes that interest rate, where you plop money in and don't touch it, like a retirement account, like a college fund, that interest rate basically can be higher at times because they're going to basically give you a higher interest rate for you keeping the money in the bank. So we're going to pay attention to the interest rate. We're also going to pay attention to whatever that monthly, or in this case, that periodic payment value is. And when we make equal periodic payments, we are going to reference this as an annuity. An annuity can go both ways. And you heard just between Jasper and Zenaria's different examples, you can hear that equal periodic payment being paying down a balance, if you're paying off a mortgage or a car payment, or even just a basic loan for any item whatsoever. Or you heard, as Ari was referenced, a retirement account, you can be building towards a specific amount. If you're with me, say yes. Everyone so far? Say yes, words. Okay, other questions so far? So, we're going to jump into trying to understand, no matter whether it's an investment or a loan, how these accounts gain and earn money or pay off money. Now, I want you to understand right out of the gate that one of the biggest challenges in understanding the difference between two different types of accounts. We're going to look at investments that grow towards a future value. And we're going to look at payments or loans that pay off a present value. So to say that again, we're going to look at investments and loans. So for the first 2 days, we look at investments only. We're going to grow towards a certain amount. Then we will go the reverse way. The earlier you start to say in your head every single time, oh, in this case, we have a college fund, we're building towards a certain amount, this is an investment. The quicker you start to, in your head, train your mind to read a scenario and say, investment, loan, the faster you're going to be able to be successful at this. Okay, so baby's born, we start putting money into an account, and we need the college fund to basically be ready 18 years and 9 months after baby's born. So we have to think of a couple specific details. First, we need to understand we're going to always reference the initial balance as $0. And as we start to put money into an account, we need to understand the specifics of the account itself. This is going to be an account that gains 3% annual interest, compounded monthly, and then pay close attention to this bullet. At the end of each month, you will gain interest. Why? Because interest is compounded how? Monthly, right? So, after, keyword after the interest applied, then your money is, the new amount of money is placed in. Now, why does that matter? It's going to matter because as we add on to get a new balance every month, it's going to matter at what point we tack on interest. Here's how it looks. The rule is, I get my new balance at the end of the month. So if I just put in my money, we don't even count that. I consider it 0, and then I start month 1 by saying my previous, that should be a keyword there, my previous balance undergoes an interest adjustment. Now we're going to only write this one time, but if you don't already have your calculator out, make sure you have it out. We're going to one time write exactly what the interest adjustment is. Okay, so if I said, hey, at the end, you're going to have 3% compounded monthly, what's going to happen? I know the answer is going to be 0 from this multiplication. What's going to happen? What would I be multiplying by? 1 plus.
0.03
Very good.
over 12.
Over 12. This previous balance would undergo the interest adjustment. And then the bullet tells us at the end of each month, after interest is applied, then basically they're going to pull the finances from one account, boom, place in the $100. Just for, oh, not yet, no. Oh, no. I see what you're asking. No, because all I'm doing is just applying the interest for 1 month.
Oh,
So the reason there's a power is because it's repeated multiplication,
okay.
but we haven't repeated anything yet. Does that make sense?
Mhm.
Okay, what is the balance after 1 month? $100. Okay. So here's what we're going to do. We're going to do one more together, and then you're just going to pair up with someone right next to you, and you're going to do 2 more on your own. Okay? So, you look at a bank statement. The bank statement says, hey, at the end of 1 month, here's how much you have. Okay. You want to know in advance, what am I going to have at the end of 2 months? So, we follow this bullet. The bullet says, I take my previous balance and do what with it? Have it gain interest. Now pause for a minute. First of all, for your own sake, will you type in 1 plus 0.03 over 12? 1 plus 0.03 over 12. What do you get? Okay. Now, if you want to use that value from now on, that's an exact value. If it came out with some sort of repeating decimal, you'd have to hang on to that repeating decimal. But I just want you to see something for a minute. Multiply 100 times 1.0025. Now, have you gained a lot of interest at this point? No, not a lot, right? Pretty low. But, with that said, that's how much is in my account before I tack on my new monthly installment. I gained 25 cents interest, and then I tack on my $100. What do I have? Obviously, $200.25. Okay, now, I want you to follow this exact pattern for month 3 and month 4. Got it? Okay, will you just compare real quickly with someone right around you? Go. Talk through what you're writing, see if you can get the right amount.
See, when you get like a long, it's just the money thing, right? I don't have to keep this decimal in when I go to the next month. You know, I think, so when I go to the next month, like this is, I think it's $300.75. I have to keep that decimal.
Oh, I see what you're saying. Before you go to month 4.
Yeah, I think that's a fine.
You can cut it off.
Okay.
Yeah, I always say that there's going to be like a dollar swing often. Because how the bank does it and how we're going to do it in class, sometimes they're going to differ slightly, just because of calculations. Yeah. But what you just said is fine for that. Okay, if you're done, let's just shout these answers out if we could. Did you get $300 and how much for month 3? How much? 75 cents. Month 4 is 401.50. Okay? I believe. I think she's right. 401, yeah, 50. Should have taken for month 4, 375?
Yeah.
Okay. All right. Okay. So what I want you to see, I'm going to write out month 3, just so you can start to see it with numbers before I change it. Because what is going to become the problem if I want to know, if you notice at the bottom, 225 months is the number of months I would have to keep this calculation going to figure out how much money is in the account after 18 years and 9 months. So as you can imagine, it's going to get annoying, right? So we're going to want some sort of formula, because otherwise we're going to have to recreate recursively depend on the previous, and no one has time to do that. And especially if you start to talk about a retirement account, sometimes those are 40 years long. Like, you do not want to have to do that by hand over and over. Okay, so with that in mind, I want to point this out, and then we're going to start to create a formula. Would you agree that this $200.25, now watch this, came from month 0 and month 1 and month 2, right? So we took my original amount, then we took this, right? And then we added on this, which would be this times this. Now, a couple things, just shout out for a quick minute. What do you notice about the numbers you see here? There are lots of what? What numbers do you see a lot of? Okay. Yeah, I agree. What else do you see? 100, right? So somehow that constant equal periodic payment is going to play probably into the formula. What else do you notice? You should see something else. Yeah, so my interest is clearly going to continue to be part of the formula as well. If you kind of see what I mean there, will you raise your hand? Okay, so go now to this slide. Because now what we're going to do is develop this in general. So we're going to say, okay, let's talk about R dollars as my equal periodic payment, meaning instead of 100, okay? And then let's talk about I as my interest rate, whatever that interest adjustment is. For us just now, it was 3% compounded monthly. But maybe it's 7% compounded daily. No matter what it is, we're going to call it I. Okay? Will you do me a favor? I just need some body language. You okay with that? Okay, so R for equal periodic payment, I for my interest adjustment. Yeah.
This might be off topic, but what if you're not paying like the same? You're not putting the same amount.
Yeah. So, okay, so for our intents and purposes, for the most part, we're going to keep it equal and periodic. It changes the game pretty significantly if you change up the payment. Now, when I say significantly, what I mean is you would have to be doing multiple calculations throughout the different scenarios. We do several problems like that. So on the first day, super straightforward. Second day, it does become more challenging where we consider 2 or 3 things at once. But the truth is, we know if I wanted to say, hey, I'm going to put $1,000 in this month, but next month, oh, I got an extra $200. I'm going to put in $1,200. Oh, next month. So in truth, you can be changing it all the time, right? We're going to keep it for our sake and to understand how an annuity works. We're going to keep it equal periodic. And we might adjust 2 or 3 times, but not nearly as many times as you probably would. So I'm going to take my initial value, and at the end of month 1, just tell me what I would do with that amount. I would take 0 and multiply by the interest adjustment. And then after that interest is applied, I will add R. Yep, very good. So my new balance is, everybody agree? Just R. Thanks. Okay. Tell me about month 2.
Put R.
I take my previous balance, multiply by 1 plus I, and now I have my interest added, and now I need to add R. Okay. Now this is where you're going to see the formula start to come into shape. To find month 3, I need to take the balance of month 2, which is here. So I'm going to take this here in green and drop it down here. This is the previous balance. 1 plus I plus R. Okay. Now, just keep in mind, this is the previous balance for month 2, but now don't change what we do to it. What do we do to it? We have it, yeah, undergo interest. And then what? Say it louder.
Add R.
And Do me a favor, cross this out right here. So you can see quickly this is going to get pretty ugly. So we got to start to see if we can find some patterns. So for a minute, I'm going to go ahead and take this and I'm going to distribute it so that I have r times 1 plus I to the second plus r times 1 plus I plus r. Now keep in mind, this is still just the balance at the end of month 3. But I'm guessing you can very quickly see the pattern enough that if I said, hey, what's the end of month 4? I bet you could give it to me. R times, what would it be? 1 plus I cubed plus r times plus r times 1 plus I plus r. Okay. Now, still kind of annoying, right? Because I need, how many do I need for the college fund scenario? Okay, so you know how it goes, right? R times 1 plus I to the 224th plus r times 1 plus I to the 223rd, all the way down. So we are going to need to take this pattern and turn it into another formula. If I want the end of payment period n. If I want the end of payment period n. I don't know if you heard what Michael just said, but Michael, will you repeat it for me? If I wanted 225, we would say r times 1 plus I to the 224th plus r times 1 plus I to the 223rd, right? So if I want n, the pattern would go r times 1 plus I to the n minus 1 plus r times 1 plus I to the n minus 2, and this would keep going. The very last two would be what? R times 1 plus I plus R. What does every single term of that very complex list of numbers have in common? Every single one of these has an R. And if I factor an r out, I would be left with 1 plus I to the n minus 1 plus 1 plus I to the n minus 2, all the way down to 1 plus I plus 1. Okay. But for one quick second, we're going to take this. Now, for a second, I'm going to leave this formula development and remind you of something. I'm going to remind you of what happens when you see a sequence of numbers like this. First of all, to help you see it better, I'm going to reverse the order. Okay? So I'm going to rewrite this as 1 plus I, and this keeps going, to 1 plus I to the n minus 2 plus 1 plus I to the n minus 1. However, if I were to help you even further see the pattern, by just extracting the numbers only, 1 plus I, what would be right after 1 plus I? 1 plus I squared, 1 plus I cubed, all the way to these last two. If I take it all the way down to this list and said, hey, I've got a list of numbers, think all the way back to the beginning of the year. What do we call a list of numbers with a pattern? A sequence. The sequence was extracted from the series, so hang on a second. What kind of sequence is this? it's an exponential. Yeah, you can say that, but that's really technically geometric. This is a geometric sequence, which came from a geometric series. A geometric series has a first term and an R. Well, this is the sequence. This right here is the sequence. It came from a geometric series, right? Series just means you add the terms. It's a geometric series where my R value, my common ratio to how do I get from term to term is what? How am I getting from term to term? If I were to just isolate, that's why the black line helps. You're just multiplying by 1 plus I. But here's the deal. If I have this should hopefully sound familiar, the sum of a finite geometric series, I can find that by taking the first term times 1 minus r to the n, all over 1 minus r. So if you're wondering where this is going, we're like 2 lines away, so hang tight. Well, this blue line can be represented by that. What is the first term of this blue line series? 1. This is 1 minus, what did Chloe just say my R is? 1 plus I to the n. All over 1 minus 1 plus I. This right here in blue can now replace all of what's here so that I don't have to calculate 200 and, I'm going to simplify it for you here in a minute. I don't have to calculate anymore even the concept of 225 times of a payment. I can instead say this. I'm going to go back to green because now we're back to the formula. The future value of an annuity in which I place in an equal periodic payment of R n number of times comes from this geometric series. Now I'm going to clean it up with one quick thing. See this minus? When I distribute it, what happens? Well, it's careful. It's not just I. It's negative I. So we're not going to want a negative interest adjustment. So I'm going to take this negative and I'm going to flip-flop these in order. What I mean is this would be 1 minus 1 plus I to the n. You see that? I didn't worry about that 1. So I'm going to take this. You ready? I don't want to lose people on this. I'm going to take this negative and I'm going to have it flip-flop these signs instead. I'm going to do this right now. You ready? Okay. So this was negative. I'm going to change this to a positive. This becomes a negative. That becomes a positive. So now my formula reads, I take my equal periodic payment and I do 1 plus I to the n minus 1 all over I. All I did was I just changed that sign. Well, why does that matter? Because I need to have a clue as to how much money I have in an account. So if you look at the next slide, I need to know how much money I have in an account after 18 years and 9 months. So we're going to use this formula. And I gave it there for you. And I'll always give you the formulas, just so you know. I will ask you at some point to somewhat show me steps of that development. But if I have R dollars and I've got an I interest adjustment, and then I turn this into something specific, like the baby that's born in which we put $100 in for 3% interest, compounded monthly, that's the problem on the front. And I say, okay, 18 years and 9 months, That's 225 payments. I can calculate the future value of my account. How? I take R and I plop it in. And then I've got on top 1 plus, what did we say I was? Yeah, be really careful here. This is a huge issue that we got to make sure we address right away. Yes. So notice, I is my interest adjustment. It's 3% compounded monthly. I address it every single time. To the N is always how many payments I make. So what would it be? 225 minus 1 all over. What's my interest adjustment only? Thank you, Jasper. 0.3 over 12. So we can now find the amount in the account. Now let me be clear, because I'm going to pull up my calculator here. Remember, I mentioned this. You really, really, really need to make sure that you have your good calculator. I will tell you that a lot of times errors just simply come from not practicing putting it in properly. So I'm going to teach you right now how to just make sure that it's in properly. You can do it all in one line. If I want to do it all in one line, I need to use lots of parentheses. So I'm going to put parentheses for the whole thing. Then I'm going to put parentheses for the numerator. And then I need parentheses for the 1 plus I. So I've got 1 plus 0.03 over 12 to the 225 minus 1 all over. And when I put that denominator in parentheses, when I put that denominator in, it also has to be in parentheses. I can actually physically see how this here matches this here. Now, if you are not getting $30,152.92, you are not putting it in properly. So I'm going to give you a second. A lot of times, and I mean 80% of the time, people know what to do. They just don't practice enough getting the proper answer in their calculator because of order of operations issues. Okay, if you're good, will you raise your hand? Okay. Any questions that you want to ask about this?
If you wanted to, you just work like inside out.
Yes, good question. So if you wanted to, you could just do one part at a time. You could find the numerator, divide by the denominator, always putting that denominator in parentheses, okay? Then multiply by 100. Okay, we're okay? What's the problem with this? Like when I think about this scenario, and for 18 years and 9 months, we're putting in $100 each month. What's just realistically the problem with that? Yeah.
It's not always, most companies are going to always be 100.
Agreed.
Every single time.
Yeah, and hopefully, I think a lot of, I know, my sister, for example, had her kids really, really young, so they weren't making a lot of money. So what they were putting into a college fund at the beginning is much different than they put in now. What else? There should be something that jumps out at you, since a lot of you are knowing the price of college. Yeah, that's like maybe a year for some institutions, and if you're going to Denison, it's not even a year. So the one interesting thing that I think you'll find through this is just the very real implications of how money gains and doesn't gain interest. With that said, I'd like to do just one more example. At the bottom, will you just, whoever you were working with, just read through that real quickly and answer that question as well. Go. Will you pick one person to read it? Like, I want you actually physically working together.
In addition to Izzy's college funds, Izzy's smart is setting aside 25 cents each month.
$25.
Oh, God.
Yeah.
$25 each month in an online savings account for assume that APR is
Yeah, good question. Yeah, this is monthly as well.
Okay.
But just know, for future reference, if you ever have a question like that, don't hesitate to ask. This would be monthly as well. Same thing. So I would like to leave here making sure that you can at least set this up properly. So when you think you've plugged in the numbers properly and you think you're good to go, will you raise your hand? So I got one person, 2, 3, 4, 5, 6, 7, 8. Brian, 9. Brian, can you give me the numbers real quick?
For
This specific scenario.
okay. Oh wait, hold on, I did it wrong. Sorry. Hold on.
That's
I have
okay.
to fix something.
Oh, you got it real quick? Ben, you got it real quick?
Yeah, 25 times 1 plus 0.0095 over 12 to the 10th power minus 1.
To the, be careful there. Yeah, so remember 120,
Oh,
because it's 10,
120
yeah, yep.
Yeah,
Minus 1 all over.
0.0095 over 12.
Okay, and for right now, we're going to leave it with that. You picked up what is considered worksheet number 4. So notice these, I'm trying to make sure we number these very specifically every time. This is worksheet number 4. There are 2 parts. There's a part in your textbook. I've given you space to include all 4 problems on this worksheet itself. And then there are several problems on the back with answers to those problems. Reminder, the answer to your odds are in the back of your book. Okay, which you can find, don't forget on the worksheet. Wait. You just got to make sure you scroll through the answer section. This also is, I'm going to be taking a lot of questions on Friday. So this also is due on Friday, but you're going to get one more worksheet tomorrow. Okay? So I'm keep giving you lots of time. Hey. I'm giving you lots of time to make sure that you're kind of wrapping your heads around this. If I were you, I would get the other worksheet done first before you move into this. Okay? Okay. So, yes, I'm going to make both of these due on Friday because I got more things that I want to do with you tomorrow.
Are we gonna have another worksheet tomorrow night?
Yeah, but it won't be due on Friday. Okay? So, is everyone clear? I'm like making sure you got lots of time to wrap your heads around this stuff, but I would do the other, finish worksheet 3 before you do worksheet 4. Okay, nice job, people. You hung in there pretty nicely.